Okay, so factoring special cases. And here I want to demonstrate something to you that the methods that we have learned thus far will still work. However, there are some times when special cases just make things easier. So for example, number one, we could do bottoms up here. So we could do 4 times 9, and that's 36. We get x squared minus 12x plus 36. Okay, then we go ahead and split that up, factors of 36, that give me negative 12, or 6, and 6, okay. If we try to divide by 4, okay, that does not divide evenly into both, okay. So we said we got to try factors of 4, which would be 2 and 2. So if we come back over here, we try 2. Well, you know what? 2 works for both of these. Okay, 2 works here, and 2 works here. So I have a 2 that I didn't use, and so I end up with a 2x minus 3. And then I have this other 2 that I didn't use over here, so I end up with 2x minus 3. And what we notice is we get the same exact thing because this is a perfect square trinomial. Now, so what I want you to understand is that the old method will work here, and if we rewrote this, we would rewrite that as 2x minus 3 squared because it's the same factor used twice. But what you can also see here is a shortcut. So I'm going to go, and now what I'm going to do is I'm going to show you the shortcut. Now, how do you recognize if the shortcut works? Okay, there's a couple of things. First of all, this has to be a square. What do we square to get 4? 2. Okay, so it's 2 times 2. This has to be a square, has to be a positive. So what do we square to get 9? 3 and 3. So what I then look at is what's 2 times 3? 6. What is 2 times 3? 6. What does 6 and 6 give me? That negative 12. So I end up getting 2x and 3. All I have to do is figure out the sign. The sign is right here, and that's what goes here, minus, and then that's a square. Now, that only works, though, because, again, this is a square, this is a square. Again, that has to be positive. And when you do those numbers, 2 and 3, 6, 2 and 3, 6, 6 and 6 gives me 12, that middle term. All right, so let's try this one. Is 9 a square? Yes. 3 times 3. Is 25 a square? Yes. 5 times 5. Again, that's a positive. What's 3 and 5? 15. What's 3 and 5? 15. What's 15 and 15? 30. So I know it is 3m and 5. Then I have to look at my sign, which is a plus right there. And we're done. Let's go to number 4. Is 4 squared? Yes. 2 and 2. It's 25, 5 and 5. What's 2 and 5? 10. 2 and 5 is 10, which is 20. So I have 2x, 5, and then I look at my sign, plus. So that's just a special case, and again, it's a shortcut. Now, these other 3 problems are what we call difference of squares. And remember, we did this when we did polynomials, difference of squares. And what has to happen here is this has to be a square, which is 1 times 1. This has to be a square, which is n times n. And then it's called difference of squares because that's the difference between them. So what we get here is 2 different binomials. One is a plus, the other is a minus. And the reason that happens, if we go back and review our polynomial section, is because we get a negative n, we get a positive n. Those cancel. That's why our n term is missing here. Okay, so let's try the next one. This is a square. What would it be? It would be 2x, right? In the other cases, we didn't put the x, but, and then 9 would be 3 and 3. So what do we have? We have a 2x plus 3 and then a 2x minus 3 because what's happening? We're missing that x term here in the middle. So one's a positive, one's a negative. They're opposite, so the x's cancel. Let's do one more. So k squared would be k and k. What do we square to get 9? 3 and 3. One's a positive, one's a negative, and there you go. So, pretty quick lesson here because these are just special cases. Again, difference of squares you need to recognize, but to know those. But the others, the perfect square trinomials, remember you can do bottoms up method and that will still work for those.